Hello, everybody. Good morning, good afternoon, good evening, wherever you are. Welcome to our webinar, Future Proofing Aviation Ops with Next Gen Weather Tech. So aviation operations with next generation weather technology, kindly sponsored by tomorrow.io. So thank you very much to them, and thank you to everybody out there joining us. You will see on your screen some buttons where you can ask questions. We will hopefully have some time for some questions at the end, but if not, please be assured that they will be answered. So if you do have any questions that occur to you as we're going through the presentation, feel free just to type those in. We'll see them. We'll get to as many as we can at the end, and if we don't, they will be answered anyway. So please do that. I'm your host, Graham Newton, editor of Airlines Magazine. We have two great speakers for you today. Dan Slagan, who's the Chief Marketing Officer, and Mark Pohl, who's the Director of Sales for Aviation. And they're going to take you through the presentation now and indeed tell you all about future-proofing aviation with next-gen weather tech. So, guys, I will hand over to you.
All right, thanks so much, Graham, and welcome everyone. It's a pleasure to be here. Real quick, we'll start with the agenda. So today we'll just do very brief introductions. We'll get into the state of aviation operations, talk about the impact that weather's having across the industry, then really focus in on the power of next generation technology and what Tomorrow.io is doing. And then, as Graham mentioned, finally at the end, we'll have some time for Q&A. Sounds good. Mark, over to you.
Yes. So this is. Thank you. Can everyone hear me okay?
Yeah.
Okay, terrific. Thank you. This is Mark Pohl, Director of Sales for Aviation for Tomorrow.io. So yeah, let's talk a little bit about the state of aviation operations. The aviation industry is facing a number of competing challenges right now, from aging infrastructure and equipment, and that includes outdated systems, software systems, to rising operational costs. That's, especially fuel, but certainly not limited to fuel. Environmental and sustainability concerns, a regulatory environment that's always changing, and of course, massive staffing challenges right now. But there's one common denominator, and that's the constant challenge that weather brings to airline operations. Weather has been a challenge since the first flights ever, but now we're seeing increasingly severe and volatile weather, which is not only, first of all, a huge threat and has massive impacts on its own, but it also has a multiplier effect on all the other challenges that airlines face in running a safe and successful business. Weather is often a catalyst of events that expose other systems in the operations downstream. So weather impacts all facets of airline operations, from ground crews dealing with lightning strikes, strong winds, slippery surfaces, to flight attendants being injured by turbulence en route, damage to aircraft and equipment caused by high winds and hail and tornadoes, all those elements that you're watching out for on the ramp. Expensive processes such as de-icing, wasting fluid from not knowing the best time to de-ice or not using the proper dilution based on the weather. And weather has a huge impact on passenger safety, on customer satisfaction with flight diversions, cancellations, on-time performance. And increasingly, it impacts an airline's sustainability and ESG initiatives as well. And we're not going to go into that in any detail today, but you should know that JetBlue has recently listed Tomorrow.io in their sustainability report based on more efficient operations and lower fuel consumption. So legacy systems are simply not getting the job done. Those systems are built on old, inflexible architecture. It's difficult to manage. It's expensive to own and maintain. It's hard to upgrade, and it doesn't scale well typically. And they also don't have the hyperlocal, high-resolution global forecasts that airlines need. They're built for raw data. They're not built for operations and for taking action. And on top of that, they often require inflexible multi-year contracts that are kind of hard to exit, both technically and financially.
Great. And ultimately, to Mark's point, there's really no scalable solution out there. Just take global precipitation monitoring as one example. Whether it's spatial coverage, refresh rate, or measurements, there's nothing out there that's giving airlines on a global basis sort of real-time and predictive data and also providing actionable insights. And whether we're looking at things like radar or existing satellites that are out there, right now there seems to be quite a gap in the marketplace, which we'll speak to a little bit. And while we have legacy systems, we have weather becoming more volatile, the threat is just increasing. We work with the JetBlue team quite a bit, amongst others, which I'll get into later. But for instance, JetBlue sees a 10x increase in the number of wind events over the past 5 years in one of their hubs. That's just one type of advancement that the team's having to adapt to. And really what we're seeing is sort of this risk of weather and climate security. We have a phrase here, we believe climate security is the new cybersecurity. But it's something, well, it's a cute statement. It's one thing that really does resonate. And ultimately what we're seeing is that, weather, in terms of the major weather events, the billion-dollar events, we're seeing, 18 to 20 of those per year, which NOAA is reporting on. But in terms of day-to-day, we're seeing 70% of all flights are being delayed due to some type of inclement weather. And airlines are just losing hundreds of millions of dollars just based on having to be reactive and being at the mercy of more volatile and severe weather across both operations as well as safety risks. And really what we see in sort of the problem and then the solution or the result of that is first and foremost, the forecast that the majority of solutions out there are providing to their customers are government-led. And these types of forecasts, it's public data, it's meant for sort of regional, broad-based, it's not meant for day-to-day operations, it's not meant for specific use cases. And so people are left with ultimately just broad forecasts that they're using. In addition, most countries and most parts of the world, think about oceans, remote parts of the world, relatively blind to real-time weather data. And so ultimately what you have is sort of weather data and forecasts just confusing and not actionable. And then what that does to the airlines and the operations is you have people being reactive as opposed to proactive, and any insights that are being provided are vague and broad. So the result here is that we're seeing increasing costs, more confusion, more safety risks, more inefficiency across operational teams, and most importantly, airlines are just reactive to weather, as I mentioned, and they can't link forecast to expected impact. And that really is what we're seeing across the existing market, and that the solutions are just not adequate. Now, we did have one poll that we were going to talk about real quick that you'll be seeing in just a moment. If you want to take a moment, we're very curious just to know sort of why, in your opinion, you're not seeing more airlines adapt to more advanced weather technology. Whether it's inadequate solutions, lack of awareness, cost, lack of standardization, resistance to change, whatever it might be. If you want to take a moment just to click through. Looks like for the most part it's kind of a little bit of everything. But if we can go to the next slide. Ultimately, what we're doing here at Tomorrow I/O is bringing next generation weather intelligence. That's the thing that we created here 6 years ago, which I'll speak about in a bit. But what we're doing is bringing proprietary global weather data, in-house high-resolution forecast models, and a weather intelligence platform that's software-based that allows you to operate on a daily basis in a predictive way. And the most important thing is that we're solving for impact. We're not just solving for weather data. We know that forecasts are to some degree helpful, but really you need to make sure that you're solving for impact in a predictive way. Now, as I mentioned, we're about 6 years old. The thing that we're known for more than anything else is we created the concept of weather intelligence. We came up with this term, and ultimately what it is, you think about a weather forecast, you get something like it's going to be 12 degrees and 40% chance of precipitation on Thursday. Great, relatively broad. What does that mean for me? What does that mean in advance? What should I actually do about it? And so with weather intelligence, what we do is while we, of course, track the forecast and report on it to all of our customers, we're telling you what to do in advance. So de-ice the plane Thursday at 9 a.m. So you know exactly what to do, and you know the predictive impact of what actually is going to happen from that weather. And just a bit more about the company. We've raised $250 million to build the most advanced weather technology in the world. We're trusted by the world's top brass. We actually rebuild NOAA's weather data model in the cloud. We advise the U.S. Air Force. We've testified in front of Congress. And both Gardner and Forrester recently named us as the sole leader across all the other companies out there specific to weather intelligence. So we're doing a lot in the space, both in terms of technology advancements as well as the actual value that we're giving to the airlines. Really rethinking the entire weather value chain. This is one thing that I'll talk a bit about now. We focus on three things: observations, advanced modeling, and then a very easy-to-use SaaS platform, complete with predictive insights. So our global observations are taking into account millions of different types of weather data and inputs that then feed into our models. And our advanced modeling system, they're really based on two things. One, it's sort of physics-based models that leverage long-standing scientific mathematical formulas that describes Earth system processes. And then our machine learning-based models that are leveraging the use of algorithms, AI, and statistical models to enable machines to learn from data and make predictions. And so unlike many other machine learning algorithms out there, our forecast, which we call 1F, we're not reliant on fixed government-generated input data, but instead we benefit from a proprietary forecasting model as well as satellite-based measurements. So overall, much like our business model, our team is able to innovate across the entire value chain of our machine learning-based 1F or one forecast-based model. And really, that's a differentiator for Tomorrow I/O, and that's what sets us apart across the machine learning landscape. Ultimately, our goal, of course, is to deliver just the most actionable and accurate weather forecast and predictive insights anywhere in the world. And finally, that easy-to-use SaaS platform, that's really where it comes into play, automated, customizable to anything, helping airline operators solve for specific use cases, as opposed to just trying to forecast weather just in general. And one particular partnership that we're quite proud of that I want to highlight is the JetBlue one. We announced this a couple months ago, but we started with JetBlue almost 6 years ago, and we were just working out of their Boston hub. And over the last 6 years, we've grown. We went to a couple more airports and a couple more. And recently, we actually announced with the entire JetBlue team that we are now their sole weather provider across all their day-to-day operations, as well as Mark mentioned on some of the sustainability goals, but primarily focused on day-to-day ops across flight operations and overall. So really excited about what is going on. Yeah.
Dan, I'm sorry, I was just going to interject on that as well. I think it's important to note that we are the eWINS provider for JetBlue for their flight operations as well.
Absolutely, yeah, I appreciate that. Great, and Mark, actually over to you to talk about how aviation orgs are using Tomorrow I/O in a bit more detail.
Yeah. So let's get into that a little bit more so we can kind of put some practicality behind how airlines actually use us. So as Dan talked about, while we invest tremendous amount of resources in our weather modeling and our forecasting capability, because that is at the heart of what we do. The best forecasts in the world are not valuable if they're not easily integrated into operations. That's when they become really relevant and meaningful to the business. And our airline customers use us across a variety of key operational channels, and I will say they're typically often coming up with new ways to use us that we didn't even think about. But those different use cases include ground operations, planning and EFB systems, meteorologists and flight crews use us, flight planning and flight following teams use us as well. And these different parts of an airline's operations use different aspects of our service. Some of them are ingesting our core weather data into their own systems through our API. So they don't even use our browser-based interface. They are just ingesting our data and integrating that into their own systems, whether they are packaged systems or homegrown systems. Some of them are proactively using our browser interface, using our map and our weather layers to get a broad view of what's going on across all of their operational areas, analyze conditions anywhere in the world, and get a sense of what those conditions are in different areas, and then drill down to the areas where they want to learn more, and they can get into very, very specific and minute-by-minute forecasts in hyper-local locations, as Dan had talked about. Others rely heavily on our insights and alerts. So they don't want to be spending all their time on the map looking for the things that might concern them. They want to define the conditions, those types of weather events that they care about, that they know that are impactful to their operations, and not think about it unless we alert them that those conditions are happening somewhere across their network. And that's when we alert the right people at the right time. We broadcast that the event is, say, it's starting in 24 hours, or it's starting in 12 hours, or it's starting in 1 hour, or we say the event has started, or that the event's finished and it's all clear. All these types of alerts are configurable and defined by our customers so that their operational people can spend their time focusing on the things that matter rather than constantly looking for the challenges that they're going to have to face. Also importantly, some of our customers use our mobile app for crew members that are either on the move somewhere, crew members that are on the ramp, the ground ops staff, and some of them are focused on upper air data and our aviation specific capabilities such as our navigational database. And let me talk about a couple of use cases in a little bit more detail here. So ground operations teams use us to keep ramps open as long as possible. Hey, Kelly, if you can go back one slide, I'll get there in a second, but I want to drill into a couple of more use cases here. So they use us to keep ramps open as long as possible so that operations can continue as long as possible, while of course keeping crew and equipment safe. So things like lightning, high winds, freezing temps, hail, tornado, those can have a huge impact on ground ops. So being able to communicate very clearly and effectively to the right people at the right time is critically important. When do these events start? When are they about to start? When do they start? When do they finish? And when can we restart operations? So, and even further in advance of that, we help with staffing and resource decisions so that they're prepared for when these events start. And we also help with flight planning, providing the ability to see all the stations across your network and to know in advance where potential problems exist to help prevent a flight schedule from getting devastated. And this is possibly the highest value solution that we provide for airlines, is just that ability to keep flight operations moving as much as possible. Sometimes there's only so much you can do. We can't control the weather, of course, but we can give the operational information at a very detailed level to help minimize that impact as much as possible. And I'll also add here, I was actually in a meeting yesterday with a large U.S. carrier, and they want to talk to us about using our forecast data to help them optimize weight and balance decisions so that they can maximize capacity and revenue. They can avoid denied boardings at the gate, and they can significantly reduce late changes to flight plans, which not only hit the bottom line, but also impact customer satisfaction and on-time performance. And they need great weather information to do that. They need it in advance and highly localized because those decisions have a huge financial impact and operational implications. Okay, next slide, Kelly, and we can dive a little bit deeper into a couple of different examples here. So what this slide depicts is a situation that one of our customers faced in the United States and the northeastern U.S. last year, where their entire fleet needed to be de-iced one morning. But in addition to the cold temperatures, there were also very strong winds present, and they couldn't de-ice if the winds were greater than 40 miles per hour. So what we did was we helped them find pockets of time where the wind was going to calm down enough to allow them to de-ice. And they were ready for it. They had the fluid and the staff on hand, the de-icing equipment ready to go, and it helped reduce cancellations that morning significantly. And they told us that they saved over $2 million in that one event. That $2 million savings based on their ability to release flights that otherwise would have been canceled. And of course, that has a huge multiplier effect on their operations downstream. And then lightning, next slide, please, Kelly. Another very common way that airlines use us is for lightning reporting and forecasting. So you can see on the frame on the right, that's actually a cell, a massive cell of convective activity in the southeastern United States. And so not only are we alerting our customers to where lightning strikes occur, and that could be cloud to cloud and cloud to ground as well, but we also identify these cells of convective activity and we forecast where they're going to move and how quickly they will move. So you can look at your airports on a map and see if those cells are moving towards you or away from you. Are they going to skirt around the side of you? You might still need to be prepared, but you don't take the same actions as when you know that a cell is coming right at you. So we provide that information, and then on the left-hand side, we also provide what's called smart boards. You can see that bright screen that's now flashing on your screen. We install those at the ramps, and those are part of our alerting system. And you can see that they not only are very visually easy to see, They also have an audio alarm, and they show where the lightning strike occurred in relation to the airport. So crews that are operating in pretty awful weather conditions sometimes and may not be able to check a phone alert on their mobile or an app or certainly their email, they're going to be able to see this and they're going to be able to hear this. So we're going to be able to provide very, very timely information so that they know when things like lightning or high winds or tornadoes are occurring or about to occur, and they need to prepare the ramp area. And then we also help them understand when they're going to get the all clear signal so that they can get things operationally moving again as quickly as possible. It's also important to note that we are investing significantly into the aviation capabilities of our platform. Kelly, if you want to hit the next slide there. So 2 of our 3 founders were actually pilots, and the needs of aviators were really at the heart of the vision that founded the company, and it still drives us today. So in the past year, we've introduced a tremendous amount of new capabilities for aviation, and those include above ground weather layers such as turbulence and icing, the ability to alert off of METARs and TAFs, and of course, in addition to the METARs and TAFs, we provide those intermediate observations for more timely alerting. The ability to monitor flights and to monitor airport conditions, so you can see at a glance what airports are under IFR, who's under VFR, what airports you might have challenges, and where you might be able to divert flights. We help you understand all that very, very quickly. And also the introduction of FIR boundaries and waypoints and nav aids, as well as SIGMETs and AirMets and PIREPs at different altitudes. And so we continue to invest. We're certainly not done. There's a lot on the drawing board, and I'll turn it back over to Dan for a look at what is coming next.
Sounds good. Thank you, Mark. So upcoming enhancements, we're really excited to talk about this. And also on the poll, just interesting to note, 41% of people said that inadequate solutions was sort of top of mind, with another 30% saying just general lack of awareness around what was out there. And so what Tomorrow.io announced in the past year and what we're about to embark on is one of the most exciting things that I've seen since being a part of this company for the past 4 years. And what it is really, if you think about the global radar gap, the majority of the world across remote parts of the world and oceans, you have over 5 billion people that are living outside of reliable radar coverage. And for airline operations, it makes it extraordinarily difficult to have real-time predictive weather updates on, as I mentioned, in real time in large parts of the world. And so our constellation, which we're working on now and goes up in the next couple weeks and months, is our Tomorrow.io constellation. We are extremely excited. We're building 30 different satellites that are going to be going out around the world. And it's going to be doing a bunch of things in terms of our ability to forecast and, more importantly, get predictive insights anywhere in the world for airlines. Right now, space is hands down the most exciting place where we can drive weather forecasts and predict how weather is going to impact our airlines. Right now, the refresh rate coming down, given there's one satellite up there right now equipped with radar, is about 3 days. That's how often we get the refresh rate coming down from the one satellite that NASA built about 10 years ago. Our satellites, when they're up there, are going to improve that refresh rate from 3 days to about 1 hour. And so what that's going to do is allow us to understand over oceans and remote parts of the world exactly what's going on, and even North America as well, in a way that we've never been able to forecast weather in the past. We've spoken to NOAA and NASA about what we're building, and one of them told us, wow, if you guys can actually pull this off, this is really one of those once-in-a-lifetime kind of industry-changing opportunities. And so we're sending up a combination of both radars as well as microwave sounders. And as I mentioned, it's going to do a number of things, whether it's helping us better understand storm structure and intensity, real-time disaster warnings, seeing where storms like tropical cyclones are actually forming over the oceans, where potentially right now we're blind to or reactive to it. It's really going to significantly change how we're able to understand weather all across the world. And specifically for aviation, there's a bunch of sort of decision-making benefits that you'll benefit from. One, first on the near-time global precipitation data, as I mentioned, over both land and ocean. This is something that we're extremely excited about that to date has not been something that's been available. Being able to model pinpoints and areas of predicted dangerous convection, operators receiving alerts, identifying which flight should be rerouted, both in advance as well as real-time anywhere in the world, and then being able to rewrite flights in advance to avoid any potential danger and damage. So there's a lot coming here. There's a lot of technology that's gone into building our first couple satellites. And as I mentioned, we're extremely excited about the launch that we are not too far away with. And so the next slide, before we get to Q&A, just want to mention one thing that we're going to be offering, and you'll be receiving an email in the next couple minutes, is hyperlocal weather consultation, whether it's for flight planning, dispatch, and ground operations. And it's a great opportunity to hop on with Mark and really understand anything that you heard today on the webinar that you'd like to dig into. Obviously, we wanted to give you sort of a high-level overview of tomorrow, what we're focused on, and specific to the parts where you're most interested or would impact your operations the best. That's where we'd really love to have the conversation with you, and whether it's around hyperlocal monitoring, predictive insights, automated alerts, the satellites that are going up, we'd love to take time to talk to you as well. So we are going to be offering a limited number of these. We'll be sending them out today, so make sure that you sign up for them as soon as you get that email in the next couple minutes. And with that, I think we can go over to questions.
Guys, thank you both very much. That was fantastic, and a lot of information to take in there, lots of questions to ask. I will just let everybody know the poll results, the latest we have. Obviously, people are still sort of adding to that as we speak. And remember, everybody out there, you do have some a button where you can ask questions. Just click on that, type in your question. We'll see to it. If we get a chance to answer it in the next sort of 15, 20 minutes or so, we will. If not, they will be answered anyway by the tomorrow team. But the poll results, just to let everybody know, so the cost, in the end, the cost factor won out, not surprisingly, perhaps given the sort of global economy at the moment. The cost factor won out at 32%. But inadequate solutions and lack of awareness around better options, they were both close behind, 25% each, and there was some lack of standardization, about 14% for that. So cost, is always an issue for airlines, and likely to be so for a little while yet, I guess. But really, it's that lack of awareness and inadequate solutions that make up the bulk of your answers there. So interesting to note. Now, guys, I will come to you. I'm not sure which one will want to answer this first, but one of the questions, very straightforward one, is obviously you've been concentrating there on sort of some of the things you've seen in the US, but you mentioned there, obviously, you're going to get global coverage soon. So do you operate globally, or do you concentrate or focus on the US?
Yeah, I can chime in. So just to be clear, we're fully global, and we have airlines that are using us all around the world. Our existing forecasting solution, as I mentioned, has sort of already been awarded as sort of the most actionable out there. The satellites really are just the next generation of where we're going to take our forecasting technology. But yeah, we also work, for instance, Azul Airlines is one example down in South America that we work with. So our existing forecasting and proprietary modeling is already pretty exciting around what we're doing. We're just even more excited about what the satellites are going to do.
And to add to that a little bit, Dan, just to add to that a little bit, as Dan said, we currently cover the entire globe. In addition to Azul in South America, we also have Sun Express Airline in Europe. But our capabilities exist around the globe right now. Now, I will say that we take inputs from a variety of different sources globally. So sometimes those inputs are higher quality in certain areas of the world than they are in other areas of the world. And I think everybody kind of understands that that's kind of the nature of weather instrumentation around the globe. But as Dan talked about, the satellites will be the great equalizer there, where we will really start to grab highly actionable, highly granular data from every point on Earth, and that will begin when the satellites go up in the air. So that's one thing that it will not only help improve our forecasting in those areas where we lack granular information right now, but it's going to improve our forecasting everywhere, because typically large weather systems start out over the oceans where there is not radar coverage right now, or there is not operationally valuable radar coverage. and we are going to address that. So having that visibility over the oceans is going to improve forecasting everywhere on Earth, including where there's already existing dense radar coverage.
Great, thank you. So not specifically regarding the satellites, because I think there you said that they're hopefully going to be fully deployed by the end of next year. But your product, how long does implementation take? And can you let everybody know what exactly would be involved? What would you require from an airline partner, for example, or any partner?
Yeah, sure. Dan, you want me to take that?
Yeah.
So, we didn't talk too much about the technology here, but I think it's important for everybody to know that our platform is all cloud native browser interface. So there is nothing for an airline to install, nothing for them to own and operate, no servers to provision, storage to provision, any of that stuff. It's all done via the browser, software as a service. So the quick answer to implementation is it's really fast, and I don't want to be too overly simplistic about it, but we can literally have somebody operational in our platform in a matter of a few minutes. Now, obviously, that's not going to get them to the point of being operationally relevant like they want to be. So the real work in getting operationally relevant is in defining what's the weather that you care about in the different locations where you operate around the world, and in defining that in our platform so that you can be alerted to those events and you can monitor those events that you care about. Now, a lot of times airlines have this defined already. Hey, if the temperature drops below X for more than 2 hours, here are the procedures that we need to follow, or the wind speeds are greater than this. So a lot of those things are defined already in operational manuals, and it's just a matter of taking those and mapping them into our platform. I'll also add here that we can get very, very granular with how we define these events. It's typically the conditions are more complex than just saying, hey, if winds are greater than 20 knots for more than 15 minutes. It's things like if winds are greater than X and the temperature is below Y, and the dew point is Z, and all those conditions persist between the hours of 4 a.m. and 8 a.m. and last for at least 2 hours. I'm kind of making that up off the top of my head, but just know that you can use Boolean logic to really define at a very granular level what are those conditions that you care about. So getting back to the question about how long it takes to implement, that's really the work right there, is kind of defining those things that you care about and then defining who needs to be alerted at what time frames before, during, and after an event. The other side, we talked a little bit about our API as well. So our API allowing you to ingest our data into your systems. Those would be typically longer implementations because you're programmatically using our data to feed your system. So that's really going to depend on the nature of the system, how much data you're ingesting, what you're doing with that data. So that's very much custom work. But in terms of our platform that most airlines use for operational purposes, it's pretty fast.
Great, thank you. And actually, moving on from that, Mark, I'll come back to you again because I believe earlier you were the one that you were talking about sort of weight and balance, and we have sort of something specific on sort of how it all works. So can you just speak a little bit more about how you help specifically with optimizing weight and balance? And does it involve actually forecasting revised schedule times, accounting for headwinds or storms and so forth?
Yeah, great question. And let me be clear, by the way, this is a conversation that came up yesterday, so I don't want to give the impression that we already have airlines that are using us in this use case. We might, sometimes we don't know all the ways that different carriers are using us. But to the best of my knowledge, nobody is using us for this. But to dive a little bit deeper into what this airline is interested in doing is they make their weight calculations and assign the number of seats for a flight and the amount of cargo they can carry. They base that primarily on historical weather data. So when they're planning their flights months in advance, they're looking at, all right, what's the temperature typically in Phoenix on June 23rd at 9 a.m. when we're going to be flying. And they use that in their flight planning calculations. And they revise that a little bit as they get a little bit closer to the flight plan or to the flight date as they're looking at what the weather conditions are. But they know that if they have better information, and if they have better information a day, 2, 3 days in advance of things like temperature and precipitation and wind speed and wind direction, all of those things are factored into their decisions when they're planning a flight and how many passengers they can carry and how much fuel they're going to need to carry. And they're looking at both, of course, the destination as well as the departure point. And so their belief is better information, more highly localized information, right? It's centered right at their airports, right on their runways, and very, very granular information. If they can dial that in, if they can move the needle in terms of better data, more accurate information for their flight planning a couple days in advance, that's going to allow them to, maybe they can open up new seats because the temperature is going to be a little bit lower than they had anticipated. Or maybe the temperature is going to be a little bit higher than they had anticipated, and they're going to know in advance, you know what, if we go with the flight plan that we have, we're going to have to leave passengers behind at the gate, and they want to avoid that at all costs. So again, it's not about achieving perfection, right? It's about improving the odds that they make the right decision on a more regular basis, or the more correct decision on a more reliable basis.
Great, thanks. Just a reminder to everybody out there that if you want to ask a question, please just click on the button and type it in. We are getting questions from around the world, which sort of speaks to that earlier question about whether you're global or not. We're certainly going out global at the moment. And indeed, one of the questions we have, it comes in from Brazil. And it's just asking about your coverage there at present, and indeed in South America in general. I assume obviously once you have the satellites up, it will be perfect. But what's the state of play at the moment?
Yeah, as we mentioned earlier, and we're already fully operational with the Azul Airlines flying throughout South America. So, the satellites currently don't limit anything in terms of our global coverage. They certainly just enhance and improve what we already have out there.
That's great, thank you. Okay, so one more question now, and I'm going to need your expertise, guys, to help me out with this, because it's, I guess, a technical question, but coming in is, do you offer a Windows-based, as opposed to iOS, EFB Live Weather Solutions? And what is the refresh rate on this data? So perhaps you can explain the terminologies there for everybody that, like me, that has no idea what some of those acronyms meant. So, guys, I'll hand it over to you.
Yeah, I can jump in there. If I understand the question correctly, can we operate in a Windows environment? Absolutely. Yeah, since it's browser based, really, Mac OS, Windows, anything that's browser native will work just fine. In terms of our mobile device, yes, that is iOS as well. So yeah, both environments are just fine. I hope I answered the question correctly there.
That's fine. I think if you say it's all going to be good, then I guess that covers it all, doesn't it? Really. So no problem.
Yeah.
One I would like to ask, I guess from my own point of view, really, is when you're speaking with clients, how do you think they view what you offer? Are they looking to have something that is purely predictive, so that they can just make quick decisions on their operations, or are they looking really to get a better understanding of how they operate, i.e. are they going to use the data just to analyze and to improve operations going forward? Is it just a quick ad hoc thing, or is there a real basis and a foundation for improving operations generally?
Yeah, Dan, I can jump in on this from a aviation perspective, and that's a great question because I've never quite thought about it this way, but I would say that that customers use us in advance. They use us at time of operations, and they also do use us for kind of post-event analysis. So, airlines are constantly trying to figure out, like, what did we do for a certain type of event, right? How did we handle it, and did we handle it properly? So doing that type of post-event analysis, and weather is not the only factor to consider, and it's kind of mind-boggling the number of elements that have to go into those analysis of events. But weather is almost always one of the factors. So airlines want to understand not only what was the weather during the event, and what decisions did we make, but they also want to understand what were the forecasts that were leading up to those events that we made decisions based on. Why did we make those decisions? How far in advance or when did we make those decisions? And then comparing that to other similar events at other cities and comparing that to how other airlines handled the event. It's a bit mind-boggling, these the analysis that's required and all the different factors that have to go into those. But weather is nearly always one of the inputs that needs to be considered in those post-event, kind of post-mortem analysis.
And how quickly do you kind of get those forecasts to one of your clients? So, you mentioned there in one of the slides about the cells over the southeastern US. And, when you see that forming, how far in advance can you say, we think you're going to have problems in 1 hour's time, 2 hours' time, 12 hours' time? How does it exactly work?
Yeah, and it really does depend on the time frame, right? So, and I don't know all the exact numbers off the top of my head, but if you're looking at a forecast that is 12 days in advance, right? Those are going to refresh, let's say on a, I don't know, hourly basis. I can't remember exactly what it is at that time frame. But as you get closer and closer to the events, in the last, 6 hours before an event, we're updating on nearly a minute by minute basis. So without going into too much detail about our inputs and our modeling and those outputs, as you get closer to the time of a predicted weather event, those forecasts are updating very, very rapidly to the point where in the hours before an event, we're updating on a minute by minute basis.
Fantastic. Okay, thank you. So we're getting lots of questions coming in. So again, people, if you're out there listening to us in live, then you'll see a button on your screen and just click on that, type in your questions. We're getting to as many as we can. So we've got a couple of questions coming in. So can you revise schedule times based on wind and storm rerouting?
Yeah,
we can't do I was just going to say, Dan, we can't do the revisions automatically ourselves, and nor do I think we want to be in that position right now, just because there's so many factors that need to be considered in those types of decisions. I would say that we are one input, a very critical input to those decisions, but those are typically going to be made through other systems, with weather being an input.
Great, thank you. Another one here that I'll just jump in if I can and just sort of use, a moderator's privilege to do so. How does this all sort of tie in with regulatory aspects? Obviously the FAA in the US and the various other CAAs around the world can jump in at any time with recommendations and their own forecasts. So how does it actually all sort of integrate into a whole to allow an airline to make a considered decision?
Yeah, that's a great question and very important for airlines. So typically, and the rules vary at different in different geographies around the world, but typically airlines are operating they have to have their official weather sources, right? Those are typically government issued or airport issues, METARs and TAFs, things like that, that they need to consider in their flight planning and dispatch decisions. But there's also supplementary weather information that they can use to enhance that. So, so we can absolutely provide the supplementary weather information, right? Which is going to be much more granular, much more highly localized, much more detailed. But importantly, Dan talked earlier about our work with JetBlue, and with JetBlue, we went through the process of becoming their official weather provider, right? So we are the source of weather information for their eWinds program. And there's a process that you have to go through with the FAA to get the stamp of approval to be that official weather source. And that's what we've done with JetBlue. We've got the procedures down. It's a process to follow, and we're very confident in our ability to do that with other airlines as well.
Great, thank you very much. Just a couple more questions before we'll need to sign off. But if you do have anybody out there, remember all your questions will be answered. The presenters have kindly agreed that they'll go back to you and email you with specific stuff, especially if it's obviously of a technical nature. But we will get answers to every question you have. So keep on typing, sending them in, and they will be answered. Just a sort of couple of specifics, really. You mentioned a mobile app before. So, what exactly would somebody using your mobile app see, and what would it tell them, and perhaps, what recommendations would it make, for example?
Yeah, so it can be used. So we have an interface that allows them to look at forecasts, to drill into a map, to look at specific areas, to look at a 10 or I think 14-day forecast at any location on Earth. But more typically, our mobile app is used for alerting and communication, right? So when I talked earlier about how we allow our customers to define those weather events, those conditions that they care about, I would say the mobile app is more typically used to communicate to people that are in the field that, hey, this weather event is going to be starting in 24 hours or 6 hours or whatever it is, or it's starting in 15 minutes. And by the way, I didn't really talk about this, but not only are we telling people when weather events are going to happen, but we are also describing the actions that need to be taken when those events are taking place. And maybe it's, hey, this is going to happen in 12 hours, and here are the things that you need to start doing 6 hours in advance to prepare for that weather event. Or the event's happening in half an hour, and here are the things that you need to be doing in 30 minutes. So that's a little off topic about how the mobile is used, but I think it's an important aspect of how the mobile application is used, because we're communicating not only when events are going to start and when they are finished, but also the procedures associated with each one of those events. And again, those are procedures that the airlines define based on their operational manuals.
That's great, thanks. I mean, when we're talking about getting that information out to the guys in the field, obviously the main ones we're talking about here are the pilots. They're the guys in the aircraft needing to know exactly what the weather is doing ahead of them. So how does that communication work, and will it change at all once you get your satellite system up and running?
Yeah, so I would say with that, that I think the last thing that pilots want in the cockpit is one more tool or one more device to look at. So we've taken the approach of consolidating with existing EFBs as much as possible, so that our information and our alerts are going through the communications channels and the devices that they are already used to seeing. And I will say, by the way, that we are not integrated into any EFBs at this moment. We're talking to a couple of them. They're very interested in integrating our weather information and our alerting, but typically that stuff is driven by customer demand. So all that really should be routed through those channels, so that the communications are going through the means that pilots are used to working with. But I would say that the communications are not typically going to pilots either, right? It's going to dispatchers, and it's going to ground operations staff, and it's going to flight planners, and it's going to meteorologists. There's just a host of different people that are receiving the alerts and communications that we provide right now.
That's great, thank you. And we have a couple of questions, sort of, I guess, on a very specific nature, and I'm sure I can guess the answer. But it's just asking about, whether you can predict, for example, fog with any accuracy 3 to 4 hours out, because obviously in certainly in Northern European climes and North US climes, that can be a big factor as well.
Yeah, absolutely. So we can, but fog is tricky, right? Just to be perfectly straightforward. Fog is a very tricky thing to predict. It can be highly localized. It can be, very transient in how it moves through an area. We do it as well or better than everybody else, but I don't want to give the indication that we have some magic wand that helps us predict fog, with ultimate precision. I will say that we've talked to a couple of airlines and a couple of airports about integrating other sensoring technology that would be installed on location, and that can really improve our ability to forecast that pretty significantly. So one of the great things about our platform being a cloud-native platform and being software as a service, we can integrate different feeds. It's something that we do, and we can do it pretty quickly, right? It can be taken into our existing models, and the output is it meshes with the output that we're providing for our customers already. So that makes us very flexible and very quick to respond. And I would say that that's not just limited to things like ingesting new sources of weather information. It's also just in terms of cranking out new functionality in our platform. We're working with a cargo carrier in the United States. It's been a customer for about 6 months now, and we've already added 5 new features, 5 new pieces of functionality based on their input when they started using us. They said, geez, we'd really like to see this displayed this way, or we'd like to see this type of communication, this functionality. And because we're software as a service, we're able to turn that stuff around very, very quickly. It's all got to be based on a comprehensive roadmap and what we feel the market needs, of course. But once we understand that, we can turn on that stuff very quickly.
That's great. So thank you both very much. With that, I think we'll start to wrap it up. So thank you both. For everybody out there, if those questions, just type them in. And of course, again, just to reiterate that they will be answered. So any questions, please just send them in. I hope you enjoyed it. I would like to say thank you again to Tomorrow.io for kindly sponsoring this. I hope you have learned a lot, and I hope you learn an awful lot more talking to them in the future as well. And with that, I will wish you a good morning, a good afternoon, a good evening, wherever you are. Thank you for joining us, and goodbye.
Thank you, everyone.
Thank you.